Let's talk about what we just taught in the last class. We know that after trigger, we taught about power supply in the last class. In fact, after the power supply, there is a critical signal, it's a power good signal. After the power good signal, there is a clock, and then the BIOS and reset can work. So before we talk about the clock, we must clarify our power grid signal. Otherwise, it's hard to teach. I don't have this order of work, but also follow this order. The MacBook doesn't have a dedicated clock chip. Its core module is integrated in the CPU inside and the bridge internal. It usually has a 24 MHz crystal oscillator outside. On the outside of the bridge of the MacBook, the main CPU and the bridge are integrated. There is another key thing before the crystal oscillator works. But generally speaking, the crystal oscillator has power supply first and then the clock. In fact, MacBook decides the PG is in front of the clock. So when we are learning the clock, we need to understand the PG first. This is maintenance. Only after PG can the BIOS be matched and the reset can be performed. Compared with the Windows, the thing less is input. Then our reset is mainly the reset in the EC and the reset in the Southbridge. To understand these two resets, what does PG mean? We first understand PG. PG is also called POC. It's called power good signal. Its full name is power good signal. It is a power source from a certain chip. What is its default operating voltage? When the Windows computer or our MacBook, which are both 3.3 volt. It's every power chip. After working normally, a PG will be generated. The role of PG is to show this circuit is good. At the same time, it can also be used as a switch signal for the next circuit with dual functions. It depends on how the engineer connects this line. So every chip will produce PG. Who will it be given to? When talking about the power supply circuit, we have talked about the CPU power supply, RAM power supply, and bridge power supply. PG is measured on their pins in 3 volt, 5 volt. Then after the PG is generated in each circuit, it will generate the all PWR good signal. This signal is also very important. After PG is generated, it will pass through a gate circuit. A gate circuit generates all PWR good and sends it to the EC. Every power supply generates a gate circuit and generates all PWR good to the EC. At the same time, we pass a gate circuit. To find out about the framework, it should be sent to the bridge PCH. There are two lines comes out from the gate and go inside the PCH. Also means that after the bridge receives this PG, its crystal really works. Because the crystal oscillator is rarely broken, but the PG will be broken. When we are repairing the MacBook, we must follow this part to check. Many people found that there was no electricity when repairing the 24 MHz crystal oscillator. And it won't work if the bridge and the crystal oscillator will change. They don't know to check these key parts I mentioned just now. And then let's look for the OPWR good signal first through the circuit diagram. You see how its circuit works. Let's take a look at this circuit diagram. Let's take a look at our OPWR good. It is a PG signal. The circuit U7960 is the first PG circuit. U7960 is relatively easy to break. Let's take a look at this PG signal. R7968, this does not exist. Remember to see the English word in the circuit diagram in the future. This line does not exist anymore, the second line does exist. This is from a 1.8 volt power supply chip. When we repair the power supply circuit, this PG signal are all 3.3 volts by default. I mentioned it on the whiteboard just now, which means the power grid is on our entire laptop, including Windows computer. It is default 3.3 volt. This PG are from different power supply IC. As long as one of the power supply of the IC is abnormal, the signal is abnormal. It will not generate this 3.3 volt, then this line is output. Usually it goes to the EC, the signal on the U7960 as well. This is its switching signal, and its voltage must also come in. You have to come in before you can go out here. It is the same as a gate. As long as there is an abnormality, it will cause all power grid to be abnormal. So in the maintenance, the circuit is also very critical. Before we check the clock, let's see if the PG signal can be found. Teach a very tricky thing, as long as the all PG signal is abnormal. Generally in our repairing, we must first ensure this PG is normal. Discover which PG is not normal. I turn off a certain resistor, so it is going with the flow of it. Usually we are repairing the machine if the PG is not normal. We disconnect this resistor to ensure that this all power grid is in an open circuit state. As a result, our all power grid will not be affected and can be issued normally. This is a case during our maintenance. In principle, we must ensure each component is normal, but in order to improve our success rate and our maintenance skills, most of the time the U7960 is broken. It is the same situation. If this 2 voltage come in but this one does not go out, then the chip U7960 is broken. We need to replace it when we are repairing it. We only remove it and needn't install it. As long as there is a guaranteed 3.3 volt normal, remove any broken one is okay. But not all can be disassembled and not installed. The PG is also the most prone to damage among repairs. It's most easily to be repaired, but you still have to look at the drawing to check. Every chip of the 3.3 volt may cause our bedside to always be abnormal. You should figure out that this is the first PG. This OSYS power grid not only sent to EC. At the same time, it will be sent to one of the gate circuits to generate PWROK inside the Southbridge. We look at our S0 PWRGD. This is just mentioned as YSO, the power grid after generating. Just now I mentioned that this power grid is produced by the gate circuit just now. Its 3.3 volt is sent here. This is a PWRGD signal inside the Southbridge. After it is sent here, it will be 3.3 volt. Send it to our U2750, which is an AND circuit. Let's take a look. This is a good signal generated by the CPU power supply chip. This is also 3.3 volt, which comes from the CPU power supply chip. There are also these two 3.3 volt are coming out, coming and be affected by the U2750. But this U2750 also needs to be supplied power, and the voltage of 3.3 volt needs to come over. In other words, there is no 3.3 volt capacitor. C2750 needs to be removed. Let's take a look. It's a voltage from 3.3 volt. After it comes out, U2750 will output it to the U2760. This is 3.3 volt again. If the circuit cannot be accessed, the U2750 must be replaced. So what happened after it receives the voltage? This chip is a good signal from AC again. This is also sent to the EC, and all power grid is also sent to EC. EC said it will be sent here after receiving it. Zoom in, let's take a look. 74VHCOA, this is a gate circuit chip. Also a 3.3 volt come in. After these two 3.3 volt come in, then generate this PM, PCH, SYS, PWR, OK out. Here are all sent to the inside of the Southbridge. This 0 ohm resistor. This PWR OKS are sent to the inside of Southbridge. We can find this PWROK inside the bridge. There are PM, PCH, APWROK, and PM, PCH, SYS, PWROK. That is to say, before checking the crystal oscillator, we must ensure this line is also normal. This is the second line. Therefore, the two gate circuits are U2750 and U2760, which are relatively easy to break. When looking for after we repair the all system power good signal, immediately before checking the clock, investigate whether the circuit inside the Southbridge is normal. Only this part is normal. Our crystal oscillator starts to work. We need to check our clock, so when we are repairing. Many technicians found that the crystal is not power on. He directly changed a new crystal oscillator. Or change another Southbridge IC, but the problem is still here. Why? Because he doesn't check and repair the circuit. So in the process of maintenance, we need to use a multimeter to measure these resistors. The resistor R2761 does not exist. We don't need to check this. Then we need to use a multimeter to measure these elements. Go and find this thing before you check the crystal oscillator. This is the second power good repair and principle.